All right. Hello. I just went for a walk, so my hair might be a little messy, but such is life. Okay. Review. There were 3 topics people wanted to review, and let me look at my notes. Even, odd, piecewise functions, and adding and subtracting rationals. So I'm going to kind of work backwards through those here. Okay. So even, odd, the way you test it is you want to see what the input does. Like if the input's opposite, where does it go? All right. So the test for this is subbing in the negative. So if I sub in the negative here, a negative times negative is a positive. And if it looks the same, right, it didn't change at all right, then we call it an even function. And even functions are symmetric to the y-axis, okay? If you always are struggling to remember what even is, your go-to function for even is the parent function of a quadratic, because that one, looks like this. And you can see that if you sub in a negative, negative times negative is a positive, and it reflects over the y-axis. So it reflects this way. So that can be your go-to. All right, so that's an even function. How about this one? Again, you want to see when you sub in the opposite, how does it behave? So sub in the opposite. Negative times negative is a positive. A negative times negative is a positive. Okay, so if I look at this, not really the opposite of that, right? I mean, this part is, but not to be the opposite. This would have to be negative. That would have to be positive. So I look at this and I'm like, neither. Okay. And we'll graph it. We'll see what happens. Okay. Let's look at this one. Again, what happens when I do the opposite? So like 3, negative 3, 4, negative 4, 5, negative 5. So let's sub in a negative. Okay, negative times negative times negative times negative would be a positive. Negative times negative is a positive. All right, so if I look at this, again, I'm like, wow, I get back to what I started from. Oops, it helps if you write it right. So this is an even function, okay? All right, let's look at this one. What happens? Well, again, sub it in. This becomes a positive. And so it's like, oh, well, these are the same, right? So again, even functions. So I know all 3 of these are going to be symmetric to the y-axis. Okay, this should have neither symmetry to the origin nor symmetry to the y-axis. Okay, and if you're like, well, what's odd? Well, how about if I do something like, say, 3x cubed? All right, if I sub in a negative, oopsie, sorry, around that one. There we go. A negative times a negative times a negative is negative. So I get negative 3x cubed. These are opposites. So remember, if it's opposite, it's odd and it has symmetry around the origin. All 3 of those O words. All right. So we'll graph this in a second and we'll figure that out. All right. Now, sine and cosine, remember, these are ones I should have memorized. Sine, when we get to trig, and of course my pen is dying just when I need it. Remember, I said I should have memorized that it looks like an S and obviously goes off to infinity. But notice when you look at this, you're like, oh, that has symmetry around the origin. Like if I rotate it, it looks like it's going to match up. So sine of the opposite of x, okay, is going to be that. And it's the opposite of what it was. So it's the origin. And when we get to trig, we'll talk about that. And remember with cosine functions, I'm like, yeah, it looks like a cup, high, mid, low, mid, high. And I should have memorized that. And again, goes off to infinity. Well, notice this reflects over the y-axis. So if I sub in a negative, it's going to just be the same as that. So this is an even function. Even if I could spell today, it is a Sunday night, and evidently I cannot. Okay, let's look at the graphs of these quick. I'm going to pause for a second and bring up Desmos. Okay, I went ahead and pre-typed in the functions just to make it a little faster. All right, this was our first one. And notice it's symmetric to the y-axis. So that is even. Here, okay, if we look at this one, it is also symmetric to the y-axis, right? It can reflect over the y, right? So that is even. This one, also symmetric to the y-axis, it's even. This one kind of has that disco behavior, right? Like John Travolta. And notice if you rotate it around the origin, so that one's odd. Did we have a neither in there? Oh, shoot, I didn't type it in right. Let's go back to this one. Sorry, I didn't type that one in right. All right, this was our neither. It's a parabola, but notice it's not symmetric. It's symmetric over what, 5 or no, what is that, 4? But it is not, yeah, not symmetric to the y. So this is the one that we had neither. Sorry, I typed that in wrong. All right, this one is our odd. Absolute value function, again, symmetric to the y, so that's even. Here's my sign. Notice again, rotational symmetry around the origin, so that's odd. And this one right here, symmetry to the y-axis. Okay, you can reflect it over, right? Okay, so that one is even. All right, I'm going to pause here, and then I'm going to jump into piecewise functions. We'll do one of those. Okay, here's another example of a piecewise function. So what I would probably do here is that this is saying if x is 2, then you only get that output. That is a point. So if I go over to 1, 2, 3, 4, 5, 6, it is a single point. Okay. All right. Not a line at 6. Now, if this is said from like 2 to 8, that your value is 6, then it would be a constant line at that. But all right. So I went ahead and did this guy. He was just a point. Okay. Let's look at the parabola part here. Well, some people like this one better. Let's maybe go here. So this is when it's 2. Now, notice this is going to be a whole. So I'm going to make my input 8 output table here. So in and out. When it's 2, I know it's a whole for my output, right? Here's my input. All right, and I'm going to go ahead and do 3, 4, 5. Now 6 is solid because do you see how 6 is included? And this is a line because it looks like it's linear, right? There's no squares or anything, nothing weird in there. So if I sub in 2, I'm still going to sub it in. If I sub in the input of 2, I get an output of 8, but I do know it's a whole. Sub in 3, 10 minus that is 7. 4, I can see the pattern, 5, and then when I sub in 6, 4. All right, this is a line. All right, so at 2, I'm going to go up to 8. So this was what, 6, 7, 8, and I'm going to put a whole. Okay, because that's what's happening there. At 3, I'm going to put a dot at 7. Oops, what's going on here? Oh, we're going down, aren't we? Sorry, oops, erase that. At 3, we're going to go to 7. And at 4, we're going to 6. At 5, we're going to 5. And at 6, we're going to go to 4. All right, and then it ends. It doesn't go off to infinity. So I'm going to connect these because obviously there's points everywhere on here. I'm just only subbing in friendly numbers, but there's infinite many points, okay? All right, so that's this part. All right, now let's do the less than. Again, I know this is a parabola. So if you want to make an input-output chart to help you out, you can. So I have in and out. 2 is going to be a whole. 2 squared is 4, and I'm going to write myself a note that that's a whole. And I might want to just go ahead and do it 1, 2, 3, 4. All right, and then my parabola is going to go here. Now this is a parent function. So if you know 0 squared and 1 squared, you know what this does, and it's symmetrical. So at 2, 1, 2, 3, 4, and this goes forever, right? So at 3, it's going to go 9, negative 3, 1, 2, 3, 4, 8, 9, and that's about it. That's going to fit here. So you want to make this curvy. It's not an absolute value function, so make it nice and that goes off to infinity, right? And so this is your piecewise function. Ignore my mistake there, right? Okay, so here's my piecewise function. If you're over here, these are your input and outputs. If you're here, that's your output. If you're a little bit past, these are your outputs, and there's nothing over here. This goes to infinity, okay? And it does pass a vertical line test, right? Even here it passes because 2 holes, it passes there, and so forth. All right, now a real life story problem might be that you work at a shoe store and you get paid, you have to sell 10 pairs of shoe, say per week. That's not very many, but whatever, it's an example, so who cares? If you sell 10 or less, you just get paid $500 a week. Okay, and we're just looking at weeks. So our function is weekly pay. All right, so you're going to get $500 no matter what. If you sell 0, you can't have negative shoes, right? And all the way up to what, 10, okay? That's what your weekly pay is going to be. But what if you sell more? Okay, so you are expected to do this with no extra pay. But if you sell more than 10, you get this, plus you get an extra $8 per pair. All right, so let's think about that. And again, sometimes it helps to do the math. All right, so if you sell 10, your output is just $500, right? If you sell 11, you would get $500 plus what? Just one set of $8, okay? If you sell 20, you would get your $500 plus you would get what? 10 sets extra, okay? If you sold 100, you get your $500 plus, let's see, the first 10 don't count, so that would be 90 times $8. This kind of helps give you a feel of what is a constant and what is a variable. These are all constants. This part is the part that varies. That's your variable. So you know this is going to be 500 plus you're going to have something here, and you know it's going to be times $8. And this is if X is more than 10. You have to sell more than 10. So this is the excess above 10. So you're going to take your input and subtract 10 before you do the 8. And you can kind of see, if you have 11, you subtract 10, get 1. If you have 20, you subtract 10, get 10. If you have 100, you subtract 10, and you get 90. And so this is your piecewise function in real life. And you could graph it. You could also simplify it, but I think it's more clear here. All right, I'm going to look at rational functions quick at the end. I'm going to pause and we're going to flip over. Okay, let's look at this. First thing is, no, adding and subtracting is a pain in the behind, okay? Multiplying and dividing is easy with fractions. You go straight across, divide, you might reciprocate, go straight across. It's the adding fractions and subtracting fractions that are a pain. If it's easy, you're wrong, okay? So first thing you want to do is get a common denominator, just like you did with fractions as a kid. 4 and 5 make a 9, so I know those are the factors. And then here, do my little factors. I know 3 and 4 add up to 7, so I can get those. All right, so what is my common denominator? Well, they both have the x plus 4 in common, so that's great. This guy has an x plus 5 that this one doesn't. So I'm going to add, or I'm going to multiply the top and the bottom. I'm going to contribute that factor to both. So I'm going to put it on top and bottom to get my common denominator. So I've taken care of that. This one has a factor of x plus 3 that this one doesn't have. So again, I'm going to put that factor on top and bottom, just multiplying by 1 really to get a common denominator. So this has those 3 factors, now this. So I have a common denominator. All right. So the next step is, here's my common denominator, and I'm going to write it. And I'm not going to multiply it out because we might want to cancel later. All right, this is where you don't want to, you might have to do FOIL, the box, distributive, whatever. I'm going to distribute. And with negatives, it's really easy to mess these up. So you can distribute and then distribute the negative, or you can maybe add the opposite now. So I might do that, add the opposite to that 4 to make it -4, and then just distribute that so I don't mess up. So -4x, -20, okay? Now I'm going to combine like terms. So what do I get? X squared, positive and negative x minus 20 all over what? My common denominator. And now it's a pain because kind of like when you add fractions, you might get something like 8/16 and you have to simplify it to a half. So same thing here. We have to see if it simplifies. So we're going to factor the top. Let's see, 5 and 4 give me a 1. I want the negative, so I need the negative on the 5 and 4, because then I get -5, +4. And then if I look at the bottom, I have those factors. And if you have a factor in common, this is a 5 there, then you can cancel. Well, notice I have a factor in common. Just like these have a 2 in common that you can factor out, this has an x plus 4. So my final answer is x minus 5 over x plus 3, x plus 5. And if they want you to multiply that out, you can. I'm okay with it left like that. So in this example, we don't have anything in common. So you're going to multiply this by the factor of b plus 3, top and bottom. And if I run out of time, I'm just going to leave it. And then here, this one needs a b minus 8. I'm going to pause and do the distributive property here just to save time. Okay, so they had nothing in common. So top, a distributive property up here, combine like terms. And notice nothing can cancel or factor out of there to cancel. So this is just my final answer. And again, if they want you to multiply that out doing FOIL or the box, you can. But you know, here adding, you don't have to be as careful because you don't have to distribute that negative. So subtraction, you have to be a little bit more careful. All right, that's just a quick review of things that people shared they might need another look at. Hope you're doing well. Take care. Bye-bye.